I'm an industrial designer, and I've been 3D printing my designs for 10 years. But for the last 3 years, I've been making videos about how to upgrade and modify your inexpensive Chinese 3D printer to make it very functional. This wannabe Prusa was one of the first projects that I ever did on this channel, and it was quite a challenge because the printer started out at such a low level. There was really so much to up that this needed to be upgraded in order to get it to an acceptable level, which is not the case with the Ender 3 Pro here. This is a solid printer from the get-go. It does the bare minimum functionality quite well, and that is it reliably and accurately lays down the filament where it's supposed to be. So that's where the entry point starts. And using that base, this printer here is the best one that I've ever made. Not because it has the most impressive functionality. I've got other Chinese printers that I've modified to do some pretty neat things. But this one is the best because it is just the most solid assembly of actually useful upgrades for the price. You cannot buy a printer that does what this printer can do. You have to build that functionality. So you can buy a printer that does what this printer can do, but it's going to cost 2 to 3 times more than this. So let's talk about those useful features, the actually useful features. This filament runout switch is just a clicky switch, just like your end stops. And basically when the filament roll runs out of filament and the tail end of that filament makes it through the switch, it pauses the printer, waits for you to load a new roll into the printer, and then resume the print right where you left off. So if you're 9 hours into a print and your roll runs out, it's no big deal. There's another sort of filament run out that people think they need, but they really don't, and that is stall detection. So if your filament just isn't moving. This can be useful for if your Hotend jams and your the pinion gear is grinding the filament and the filament just isn't moving. But with the dual drive pinion gear here, that is this extruder assembly, or what would we call it, like a capstan pinion gear assembly, there's 2 wheels, each of which are tied to each other through a gearing, and so they both are pinching against the filament which runs between them, and they're both feeding, and your likelihood of having that grinding condition is almost eliminated. So that's the solution there. And Creality recently released this this capstan assembly, so that's the way to go there. You can see it running directly here on a direct drive extruder assembly because I've mounted the capstan stepper motor right here above the Hotend. Now normally on an Ender 3 and an Ender 3 Pro, this motor is mounted back here and you have a Bowden tube setup that goes, you have a piece of tubing, Teflon tubing, where the 1.75 millimeter filament feeds through a 2 millimeter orifice in the tubing. So that can lead to problems. That 0.25 millimeter of slop, of wiggle in that hole, down the whole length of Bowden tube means that filament can kind of get wavy or sort of spiral inside of the tube, and it sort of compresses when it's spiraling, or and it has to unstretch. So that makes your retraction moves less effective. When you have a direct drive, your retraction moves are just far more accurate. So direct drive gets you better quality prints at a cost. Direct drive adds a lot of weight to your X carriage, which leads to ghosting or ringing. However, in software, you can eliminate the ghosting or ringing. There's a fancy feature. We're not going to get into it in this video, but so there's solutions. Still, the ideal printer, if we were just going to spend all of the money, would not be this, what is this, a Mendel-based design with this moving bed. That's already got some mass, so who cares if we're adding a little bit more mass up at the top here. But ideally, you would have the bed moving just a little bit in in Z, like you see on a Core XY, or even the other style of box printers like with the Ender 5 or something like that. That is a much better design as far as inertial mass goes. However, it's more expensive because there's more complications to the frame of the printer. So this is just the way to go because it's the least expensive. But yeah, even better still for speed would be a Delta printer. And you can go watch my recent videos about Delta printers. They are very fast printers, maybe 10 times faster than this one. I mean, that's the upper limit. That's printing really fast, but it's just so much quicker when you eliminate that inertial mass. So yeah, but for price, you can't beat this frame design. Now, moving down the line, we've got a BL Touch bed leveling sensor, and that directly measures the print surface. There's other techniques for directly measuring print surfaces, but this is sort of this out-of-the-box, ready-made solution that's pretty easy to implement. So yeah, it's actually really, the complications are way less than other sensors, and it just works. Unlike the very inexpensive, inductive probes that are measuring the substrate, the aluminum underneath the print surface. Those are like $3. So you're going to pay the money for the BL Touch, $40. It's pretty expensive, but hey, you pay for what you get, and it's well worth it. Just the added functionality that it gives you, that's a good place to spend money. I'll tell you what's not a good place to spend money is the bracketry to hold the direct drive motor there. You can go spend $20 for a piece of bent aluminum on eBay from China to change your printer up to being direct drive. Why? When you can spend 50 cents to 3D print your own bracket and accomplish the same task. So save the money where you can and spend the money where you need to spend it. This build uses my split part cooling design, which is something I'm pretty proud of. Actually, that's a geometry that I came up with like 2 years ago, maybe, when I got my first Ender 3, and many people, Patreon supporters, have downloaded and installed that on their printer, and it works great for everyone. So the benefits of my design here are the fact that it uses the stock fans, so you don't need to buy a new fan, and you don't even need to change up the wiring or extend the wiring or anything like that. The little tiny blower fan here is mounted at a 45-degree angle, so that air is already turned. Every time you turn the air, or the longer the runner is where it has to flow, the more it slows down, and that means the less effective your part cooling is going to be. But by having this very short path to travel and that angled fan, I get really good airflow at the nozzle. And split part cooling means that you get 360-degree cooling. 180-degree ducts or circles even, where they try to get the air all the way around to the other side, are just ineffective. But by having two separate blasts coming in from opposing sides, yeah, that's a great solution that I've got there. Over here we can see a brass wire bristle brush, and that is an idea I got from the $3,000 Ender 3 tool changing, I'm sorry, not Ender 3, E3D tool changing printer, and I just put it on my Mendel design printer here. So anytime you slide the Hotend or X carriage off the side of the bed there, it's going to clean that nozzle, which is very useful when printing PETG. PETG tends to string, the strings build up on the nozzle, and then that nozzle is basically a big ball of glue which can grab your print as it's supposed to be clearing over the top of your print, but it can accidentally grab the print and tear the print off the bed. You can get layer shifting, there's all kinds of problems. So by being able to clean your nozzle means you avoid those issues with PETG or other filaments that have stringing issues. Speaking of things getting torn off the bed, let's tear the bed off the printer entirely. This is a flexible flex steel plate with a PEI sheet, which is basically taped down to it. And this is a nice solution for parts, for being able to peel parts off the bed. Because let's say you printed the part all the way to the edges. In order to get that off, you just have to flex this like an ice cube tray and it pops right off. That being said, it's useful. $40, which $45 is what that costs to get one of these complete kits: the magnetic sub bed, the flexible plate, and the PEI. So that's kind of expensive, and I'm not entirely convinced that it's that much better than an ultra base. So a glass. You can also just get normal borosilicate glass for very inexpensive. But the problem with those is you have to use a sharp putty knife. So I've sharpened this one. It's not razor sharp, but it's pretty sharp, you guys. I can almost use it as a knife. And the proper way to use these is to put them flat on the bed and to flex them up like you see me doing here, and then slide it sideways. And to hold behind your part. You never want to be trying to push it into your hand. So there's many gruesome photos online of people's left hands from trying to get a part off, and it pops off all of a sudden, and then that knife gouges their hand up. So yeah, to avoid that, the flexible PEI surface is kind of nice. But yeah, it's a marginal utility one, you guys. It's nice to have. It is. Still, I have borosilicate glass on some of my other printers, and I don't mind. The glass is very tough, so you can take the knife to it all day long. It's pretty much just gouging your hand that you have to worry about. All right, over here we see the cooling tower that I've done, and that allows me to replace 2 fans that came on this printer. The stock board cooling fan, which was underneath here and just sounded like a jet airplane taking off. That thing is ridiculously loud. And then there was also a fan on the power supply, which cooled the power supply. So by putting a single 120 millimeter fan that cools both the control board inside of this green tower here and the stock power supply, I'm eliminating the noise. I've got a silent fan doing the job of 2 other fans. So that's a great upgrade as well, because honestly, trying to work in the same room as a 3D printer that's noisy means you don't get as much work done. I have tried. It gets to you. That noise for 10 hours during a 10-hour print, the constant fan noise, it grates on you. So speaking of control boards, inside there is a Duet Wi-Fi control board, Duet 2. And that control board nearly doubles the cost of the printer. So I can already hear you guys, every time I talk about a Duet control board, somebody wants to chime in and talk about how egregiously expensive a Duet is. But you know, it's like I've been saying, you want to spend the money where it matters and save the money where it doesn't matter. And the Duet control board, there's nothing better in 3D printing. Seriously, I almost see all of my printers as Duet printers that just happen to have frames made in China. It's that important. The control board is the brains, it's the center piece of the printer, and well worth the money in my estimation. The BL Touch sensor, also in a similar boat. So yeah, there you have it. You've got direct drive, filament run out, measuring directly to the bed, which is a really nice, easy to use, to pop the prints off of it. You can clean the nozzle so you get much more successful prints out of PETG, and you can wirelessly send prints to your printer from your computer without ever having to engage with the printer except to load the filament into the Hotend. Also, that wireless functionality, just the entire functionality of the Duet can't be beat. You can change the firmware, you can upgrade the firmware, and then you can change your firmware configuration file all through your web browser, on your phone, on your tablet, or on your PC. So that board is just super impressive. Now, I've started this build on my Ender 3 Pro here, but I don't recommend that you do it with an Ender 3 Pro. I actually recommend that you start with an Ender 3. I don't see the benefit for the extra money. This power supply is an upgrade. It is nicer, that's true, but the power supply that comes on the regular Ender 3 does the job just fine. And I have geometry for all of these upgrades that you see here that works on the Ender 3 as well as the Ender 3 Pro. All right, well, let's jump back in time to a point where I had just sort of disassembled this printer in preparation for this upgrade here, and we'll just pick up this build at that point. This particular geometry works on the Meanwell power supply on the Ender 3 Pro. In total, I've made 4 versions of this cooling tower. The first one on the left here is for the regular Ender 3, the non-Pro version, and it houses the stock control board that comes with that printer. The second version here, also for the non-Pro version of the Ender 3, and it houses the Duet 2 Wi-Fi, the Duet 2 Ethernet, or the Duet 2 Maestro boards. The third version is the one that we just were looking at on camera. That is for the Ender 3 Pro, and it holds the Duet 2 Wi-Fi, Ethernet, or Maestro. And the fourth version here is for the CR10, the normal, just bare bones CR10, and it houses any of the Duet 2 boards as well. I also have mounts for putting the Duet inside of the stock, case here for the electronics. And even though it's cool maintaining the stock appearance of this printer, in my experience, it's a really poor housing solution for the Duet boards. It's kind of cramped, and that stock cooling fan that comes on these printers is really obnoxiously loud. Getting a quieter fan to fit in that case would be really a challenge. And the other thing we're going to remove is that stock screen that comes with the Ender 3. It's called a 12864 screen. It's 128 pixels by 64 pixels tall. And it's just this click wheel screen that just doesn't work that well. It does have compatibility with the Duet 2 Maestro, and that means that the library has been written. The implementation to use it with the Maestro I found to be kind of buggy, and I hardly ever used it. The ability to control the printer through a web browser on any device means you can just pull your phone out of your pocket and control the printer while standing at the printer, so you don't need a screen attached to the printer. But Duet does sell one. And that's what it looks like when it's fully installed, and I can't even hear it running. That fan is almost silent, so it's awesome. Now I'm going to completely skip over all conversation about wiring here in this video for a couple of reasons. First of all, Duet has released this diagram, which shows you where everything goes on their control board, and also I have an entire video dedicated to the subject of how to wire an Ender 3 with a Duet control board. So go watch that if you don't like the diagram. But I do want to say one thing about the wiring, and that is the fact that I wired this 12 volt fan into one of the always-on slots on the Duet board, and that slot is feeding 24 volts. So in order to not burn up the 12 volt fan, I used a step-down voltage regulator like this one. This is the sort of the old school style, and you can find these on eBay. They're like $3. There are dedicated screw bosses in this case that I've designed in there so that you can screw down. There's a place to mount these old style buck converters, which is nice. But you don't have to use the old style ones. You can use one of these, which is the new style, tiny little one. But whichever one you choose to go with, be careful, you guys. I accidentally touched my buck converter input, so one of the 24 volt lines, to a component on the Duet board and completely fried one of my Duet boards last year. So, you don't want to be wasting $175 like I did that time. All right, the next step is to teach the Duet board about the Wi-Fi, the wireless network here at the house. So I need to connect the Duet board to my computer with a USB cable in order to teach it that credential. And then once that's done, I can basically connect to the Duet board wirelessly through the web page and do everything else that I need to do, including updating the firmware and installing the configuration file. So let's jump on the computer and make that happen. One quick note before we do that, it's tempting to want to wire the 120 millimeter fan here into the connector on the power supply PCB where the original power supply fan was connected. But don't do that, otherwise you'll get the weird pulsing on and off when there's a load on the bed. It's not temperature determinate, it's just load determinate. So better to just have this silent fan on all the time. Now do a Google search for getting connected to your Duet and this website will pop up. If you don't want to read anything, I've actually made a video on this subject as well, link in the description. But basically you open up a terminal program. I'm using YAT here, and then you just make a new connection to your printer, which is connected to your PC via a USB cable. So here we are, and then you just enter in the command M115 here in the text field. Enter, and that will tell us that we are connected to our RepRap firmware Duet running RepRap firmware, and the firmware version is 2.03, and I believe the latest up-to-date version is 2.05, so we'll get that in a minute. But there's also a whole new firmware, which is 3.0 firmware. So we're going to first start off with the 2.05. And the way we're going to do that is here in the RepRap configuration online assistant. So when you come here to the start tab, here at the top, there's a bunch of tabs that you can go through. You come to the start tab, you can click this use existing configuration radio button, and you'll be prompted to load a config.json file into the configurator here. Now I've loaded in the config file from my Maestro board, which is what I was previously using. You can see here the board is Duet 2 Maestro, so I need to change the board to being a Duet 2 Wi-Fi, and then the firmware to being 2.03 to 2.05 right there. And we'll just name this printer Ender 3 Pro. Okay, so the rest of my settings should be pretty spot on. The heaters, I believe, are a little bit different for the Maestro, and there's a couple of other things that I need to go through here and change, but I'm not going to bore you guys as I go through all of the boxes. So we'll just cut to the end here at the Finish tab. We're going to delete this functionality for the 12864 display. That's the display that came stock on the Ender 3. We don't need that. We got Wi-Fi web page interfacing to this printer. Much better. So click the Finish button here, and you can see these two things for downloading, as well as all the configuration files for the printer. So we'll just download these one at a time, and then we'll download the configuration bundle as a zip file. Back to the terminal program here, you're going to want to type in the command M552 space S0. That turns off your Wi-Fi module on your duet. Then you enter in the command, which I'm showing you on the screen there, except change the words inside of the quotation brackets to be your network SSID for your router, your particular Wi-Fi router, and also your password. And once you've entered in those variables, you can type in M552 space S1 to turn your Wi-Fi module back on. Then you can type in M552, and that's it. And that will return an IP address to your printer. Go into your web browser and enter in that IP address into the address field, and ta-da, you are now connected to your printer. What you're looking at here is the old web interface. Maybe maybe the board that you order will have this, or maybe it will be the updated version. We click on the settings button, and then the upload files button. Now you can upload all the files for the firmware upgrade, for the web interface upgrade, as well as the just the configuration files through that button. And this button has changed its location in the newest version of the web interface, and we will see that here in just a second. And then here in my downloads folder, we can see we've got all three things which we're going to need right now. So we're going to start with the combined firmware. We're going to open that. And we can see we've updated the firmware. We are now in version 2.05.1. So let's upload the actual config file. And then we can head up here to machine control, and we should be able to do everything we need to do to the printer. Let's try a home all. So let's test the heaters. We'll turn both of these on. Let's just turn to 30 degrees. We don't have to get them real hot. We just have to see the temperature rising a little bit and see the, see that the heaters work. So both those heating elements are heating up right now. We can see the temperature going up. So everything works on this printer. We can send a test print to it and be done with it. But you know what? I'm not even going to bother. Let's just go straight on to RepRap Firmware 3.0. And back to the online configuration assistant we go. Starting here in the general tab, we're going to change the firmware to 3.0 or later. You'll notice that there's this whole IO mapping tab now with a lot of fields that are pretty important. This is a change for firmware version 3.0. And we can see I've got firmware version 3.0 installed. Let's say I'm here, my printer is nice and cool. The bed is sitting at room temperature, 28 degrees, and I want to get the bed up to 100 degrees. So let's just turn that heater on, and we get this error that pops up. Error, heating fault on heater 0, temperature rising much more slowly than expected. We can look at it here in the console as well. So yeah, basically it's now popping a fault on heater 0, and I can click that and clear the fault, but it makes me read this text first, which is this sort of, it's just watching out for you. Don't want your 3D printer to catch on fire. So I like the fact that thermal runaway protection works on Duet, but it's set to be a little bit too sensitive here. And basically it's doing PID type thermal runaway protection when it should have its own setting for the bang bang. So here I am on the GitHub repository page downloading the latest version 3.01 RC12 of the firmware. You can see I've got that installed now, 3.01 RC12. And yet the problem persists. So clearly version 3.0 of the firmware is not ready for prime time yet, at least not with the 2.0 version of the board. So this is a Duet 2 control board
running firmware version 3. Now there is a Duet 3 control board, which is a lot of overkill for a 3D printer. And that is, I think, the primary reason that they created firmware version 3. And I don't see any real advantage to firmware version 3 running on a Duet 2 Wi-Fi. So yeah, 2.05 is going to be just fine. And I'm just going to backdate to that stable release that I know will work and do a test print. And if you're seeing this video sometime in the future when it's likely that Duet has fixed these issues with the firmware version 3, go ahead and send me a message over on Patreon, and I will get you the very latest configuration files that go along with this printer compatible with, RepRap firmware 3 point whatever is current.
Before I do any test prints, let's cover some of the other, things that we should cover about this printer. First of all, there's a dedicated video talking about the filament runout switch here, which is integrated into the extruder mechanism. Also, there's a dedicated video about the nozzle cleaning brush down here. Now, just a quick side note about that. Somebody in the comments asked why you need to clean your nozzle every layer. Well, you don't need to do it every layer, but what happens is your PETG prints tend to string. They leave little wispy hairs that sort of float above it, and the wind from the part cooling or just general movement of the print head across the print will suck those hairs up to where they'll touch the nozzle. And when they touch the nozzle, they turn molten and they stick to the nozzle. And through the course of a whole print, this builds up on the nozzle. And if you look at your nozzle on doing a PETG print, it's coated with plastic. And this can be a problem if you have like a fragile portion of your print where that big globule of PETG on the nozzle can catch the fragile portion of your print and either pop it off the bed or break it off or lead to other problems. So by keeping your nozzle clean, you don't have this issue. So sure, you can eliminate stringing in your slicer software by getting your settings just right, but there's always a trade-off. So, if you lower the temperature, helps with stringing, you're also lowering layer adhesion, which is bad for part strength. So it's nice to have a sort of fail-safe way of accomplishing that task. So I think I'm really proud of it. I think it's one of my best upgrades. I definitely recommend you guys follow suit and make that yourself. So link in the description to both of those videos about those upgrades. Speaking of printing with PETG, let's talk about print surfaces for a moment. I showed this in the intro, but hey, here's the print surface that I use, which is just this eBay special flexible, so it's flex steel plate with a PEI sheet adhered to it. This is not the fancy powder coated version. And I found a version currently for sale on eBay for $45. So that's the way to go. You get the flexible steel, you get the PEI sheet, and you get the magnetic underlayment, all of that for like $45. The problem is, make sure you put a little baby powder, a little talcum powder down the first time you use this. I didn't do that, and you can see there's portions of my magnetic bed that have peeled up. Those were stuck to the bed the first time I left it overnight or whatever. So just a little thin layer of talcum powder, and you won't have that adhesion problem. Now, the Ender 3 Pro here comes with a magnetic, like this, real floppy magnetic print surface, and it works fine. It really does. But there's a problem with it. If you send a print and that print nozzle is too close to this surface and you're printing with PETG, you will never, ever get the PETG off the print surface. It's not going to happen. This one got fused. I accidentally pretty violently bumped my print head here and threw the calibration of my BL Touch off. And so I was printing printing right on the thing. So I was 0.2 millimeters lower than I was supposed to be. And that's tearing the bed off rather than separating the print from the bed. So you can tell, obviously, I was printing one of these. And you can see those wispy hairs that I was talking about a minute ago with the buildup on the nozzle. So yeah, I don't really like the floppiness of it, and the PETG sticks to it too vigorously. So the PEI is actually, I think, the best way to go. So winner there. Now, this is the strain relief part from the back of the bed here. And I had to remove this because with this attached, I did not have enough length with the stock wiring to get full motion from that bed. But but with this removed, it fully works. Now, this is a nice part to have in theory, but in practice, I have only ever found one time that this strain relief was something that mattered to me. And that was when I soldered the leads onto the bed myself. And my soldering iron's not that powerful, so I didn't get really good flow of the solder to the bed. And so over time, that sort of fatigued and fell off. These, beds coming from Creality are soldered quite well. I don't think we're going to have an issue without the strain relief. And it doesn't work with it. So it's not ideal. Maybe I should make a shorter version of the strain relief or something like that. But for now, we're just going to leave it, and I think it's going to be fine. For anyone who doesn't know, the Creality Hotend is pretty decent. It really is. It does a great job. And it's almost comparable to a E3D design, except that the Bowden tube, which goes all the way down until where it touches the nozzle, it goes all the way down in the hole there. And the problem is that the Bowden tube can separate, and there's a little air gap between the nozzle and the Bowden tube. And so the sides beside the Bowden tube tend to fill up with molten filament, which makes a very sort of friction path. There's a lot of friction then to try to push the nozzle, to push the filament through the nozzle after that happens. So seating that Bowden tube fully to the nozzle can be a problem. And there's a fix by a guy named Luke Hatfield on Thingiverse, which I'll link in the description down below. Although Chep has talked about it, it's pretty well known on the internet. And that's what this is. So I'm going to do that fix as well. It just involves a little washer and cutting a piece of Capricorn ptfe tube to length. Now, I do recommend Capricorn tubing. It's got higher heat resistance. And the crazy thing about ptfe tubing is this stuff is basically Teflon, the same thing as in your cookware. And if it gets hotter than 265 degrees, it releases nasty, nasty chemicals. Like we're talking like nerve agents and stuff. But you can see here, this one that's been sitting down there has some gunk on the outside because of that sort of backflow. So everybody has this problem to some extent. I personally had that seated well enough that I wasn't getting the friction, but this is a much better solution. So go ahead and do that. It's basically a free upgrade. You just have to get a little section of Capricorn tubing. Although this will work just fine. This is just better. This is my split cooling fan duct design, and it also holds the sensor, the BL Touch sensor. So I'm really proud of this. It's probably one of the best things I've ever made for these 3D printers, just because it is so compact and it does such a great job using the stock fans. So there's this little stock fan, and unlike the the Pet's Fang, which is a thing you find on Thingiverse that sits way up here, so it's all kinds of bulky and also requires you to buy another fan just to get the airflow that you need. By mounting the stock part cooling fan so close to the print and also angling it at 45 degrees, I've got really short runners here, which means that I don't have restriction of my airflow. So I get plenty of airflow at the nozzle, and my part cooling is as good as you'll get with any other design. But it's also got an integrated BL Touch mount. You can see on this version, I've put the brass inserts for the threads, just because I do take my BL Touch on and off from time to time. But I have a version of this part that I've made without brass inserts if people want that, because you can thread directly into the plastic. It's every bit as strong, pretty much, as brass inserts. There was a video by another YouTuber. You can go check that one out if you care. So yeah, I'm going to put this one on because the other one that I have here broke on me. That was that time that I told you that I bumped the Hotend pretty violently. And both of these prints are made with polycarbonate, which I now have the ability to print. I have a heated chamber that gets very hot. Polycarbonate is well beyond the scope of this printer here to print. I'm printing at 330 degrees. The max temperature for this is 265. So polycarbonate has great heat resistance, and that's why it's the superior plastic to use for this part that gets close to your Hotend. However, I found that printing this part with ABS works just fine. Even printing ABS using this ABS part cooling duct, I still didn't even get any real deformation of the part. So yeah, this is a great part, fantastic upgrade. It's kind of the core of my printer upgrades. But today we're going to be adding something more above it, and that is this bracket right here that will sit like so and this bracket will mount the extruder capstan motor as well as my filament runout switch. So what we're going to have then is a direct drive Ender 3 for the cost of a bracket. Printing a bracket was like $1, maybe 50 cents worth of material. So just a fantastic upgrade because direct drive printers make better quality prints as far as the retraction moves go. And retraction is a very important part about getting quality prints. However, direct drive extruders come at a cost, and that cost is inertial mass. So having this heavy stepper motor getting thrown back and forth, the law of inertia, it doesn't want to stop. So if you're moving here and then moving there, it wants to keep going. And so that leads to shaking. And as it's shaking, as it turns a corner, as it tries to change directions and it's shaking, it manifests on the print as ripples or ghosts. So you have to slow your print speed way down, but once you slow your print speed down to remove ringing or ghosting, you have the benefits of limited artifacts from the retraction settings. And so yeah, basically it is true that direct drive is superior to Bowden tubes. Now I've poo-pooed it in the past in favor of Bowden tubes because of that inertial mass issue, but here's the thing, I took this bed off and I weighed just the bed, not the sub bed or anything else like that, and just this bed alone weighs as much as this motor. So in other words, it doesn't make any sense to have less weight going up and down the x-axis if you've got a whole bunch of weight going in the y direction anyway. So you're going to have to print as slow as your heaviest axis will handle. So you might as well make both axes of movement weigh the same. So that's going to be a nice upgrade. So let me just snap my fingers and that will all be mounted. And there it is. But hold up, I hear you saying, that's not your extruder, and you're right. So I'm really proud of this project. This turned out really well. See, when you wind through it, it runs out of filament. That pops open, and the sensor here, the optical sensor, trips filament run out condition. And like I said, this has been working on my printer for more than a year. It's been under tension. I've got the ability to put 2 springs there, so you really bite down on that. But that spring tension is the problem. See, these 2 arms are meant to be parallel. They're meant to sit like this. And this unit has been on the printer for more than a year now, and under constant spring pressure, those arms have spread. That's called plastic creep. That's the name of the issue. And basically think of your plastic as water. It's like really viscous water. And so even, like ice, glaciers move slowly. So even when they're frozen, when the plastic here is in its frozen state, and even when they're frozen, they can still flow and move. So there are a couple of solutions to this. First of all, you can just make a couple of these arms and just replace them as they spread. So every 6 months or so, just put a new arm on there. The other solution you could do is to, and I've got this in the files there for my Patreon supporters, there's discs, spacer discs, because that's a really deep pocket there for the spring to sit into. So as this spreads open, you can put more discs in there to just keep up with that spread. And what I've done here is the easiest solution, and that's just to take that spring off and stretch it. Just give it a little bit more stretch so that it's so that it can spring a little bit farther and take care of the issue. Now this unit, even with the arms spread like they are, still works perfectly. So it's still a great project. I'm still really proud of this. But the final solution is to print with carbon fiber or fiberglass, impregnated filament. So here I have some PETG with carbon fiber inside of it. And the next iteration, I'm going to print out of this. If you have carbon fiber or glass-filled filament, you will no longer have the heat creep, or I'm sorry, not heat creep, just the regular plastic creep issue with your parts. So that's the easy solution, but this requires a hardened nozzle, or I guess you could get away with printing about that much of a print with a regular brass nozzle if you just wanted to throw away the brass nozzle and replace it as soon as you're done with your print. So yeah, anyway, I do need to reprint that because I need to redesign it. There's a number of problems with this particular design trying to use it in this position. Now it worked fantastically mounted back here at the back of the machine, but when it's here, first of all, the arms back here are going to collide with the upright. And also at the top, they're going to collide with the top, so it'll limit some of the travel in the Z direction as well. So that won't do. I need to come up with a new solution. So look for that in a future video. But for now, I've got one of these dual drive, what would you call this, capstan pinion gear assemblies from Creality. I think this came from Creality. It might have just come from some other random Chinese supplier. Now, if you get the official one from Creality, it might be higher quality because the ones that I'm getting here have this normal screw. This is just an M3 screw that goes through the driven gear with these little bearings. And these little needle bearings are meant to ride on the M3 screw. That's just terrible. You can't have needle bearings riding on threads and expect very good results. This should be a shoulder screw. And I'm sure that this is it looks exactly like the one from, who is it? Bondtech. So this is basically a carbon copy of Bondtech's technology. And you guys all know how I feel about copycats and clones. But it's a subtle thing, right? We have to advance the tech. Things have to get better. So there are other ways that they could have implemented this driven gear thing, but the fact is this bears no resemblance to a Bondtech. It really doesn't. So nobody that was going to buy a Bondtech will buy this instead. It's just not going to happen. So I think that this is an okay gray area where they're clearly learning from Bondtech's products and making them worse. That's not even comparable in quality to a Bondtech. And yet you still get the dual driven gear assembly. And the filament runout solution is just one of these filament runout switches that you can get on eBay for a few bucks as well. So you'll want to cut an angle into your filament to give it a nice sharp point to help it guide through the filament path here. And then you just slide that through like so. Come over here and slide it in there. So the nice thing about the filament switch here that floats is it makes it so that you can grab the filament here and you have more control when loading the extruder. So some of the other solutions coming from China rigidly mount this right outside of the extruder, which makes it difficult to get the filament all the way through there. So I actually think that this floating switch is a better solution. And as far as the wiring for the Hotend X-axis assembly goes, you'll need to get a 1 meter long stepper motor wiring harness. Actually, you'll need 3 of these 1 meter long wiring harnesses. One for the X-axis, one for the Z-axis, and one for the extruder. Because the stock harnesses aren't long enough to make it from the control board all the way across to this side of the printer. Hopefully the filament runout switch that you get comes with these 3 wires that are long enough to make it to it, but if not, you can just cut the wires and splice a little bit of extra length onto there. All right, the last thing to do is to calibrate the offset distance between where the BL Touch probe measures and where the actual nozzle height sits. So that is something that's pretty easy to get done using the macros that I have set up on my duet board. So let's make that happen. All right, we will start off by homing the machine. And then I have these macros called changing nozzles. Now, since we're not actually changing the nozzle, we don't need to heat it and remove it. So we're just gonna go to the move to Z3. And that also disables software end stops, which is something you need to do. Now it's time for the paper. So you stick the paper underneath there and you use these lowering commands to lower it down until the paper has friction, until the paper is being pinched between the nozzle and the bed. Now as a quick shortcut here, I like to enter into the command G0 Z1. Just to quickly move it down because the movement is 0.05 millimeters, so it goes kind of slow. Okay, so I'm gonna set this down on the desk and I'm gonna tap that Z negative movement for 0.05 millimeters as I'm measuring with the paper. So tap, 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 tap. Yeah, that feels good, just a little bit of friction. So now I use the macro here, reset Z lift and probe, and it's going to give me a Z height value of 1.02 millimeters. So that means that I need to change my sensor offset, aka the trigger height, in the config.g file to show that number instead.
So going to System and then config.g, scroll down to the Z probe header, and under the G31 command, there is the offset for the Z distance, which needs to be set to 1.02. Save and reset.
Now we can measure a grid of points for the bed leveling algorithm, G29. And then if we want to see what's going on there, we can just select the height map here and take a look at that height map. So looks like we're pretty low. It sort of droops down right here at the front edge of the bed, and the back of the bed is pretty level. But I've got the plane of the bed in a good orientation, so that looks good. But I made a mistake. You don't want to do that bed leveling algorithm until you've got your bed up to print temperature, because basically the inside of the bed gets hotter than the outside of the bed, which is able to radiate more heat out here. There's more surface area. So the inside of the bed, the material expands more than, because it's hotter, so it expands more than the outside. And that tends to sort of dome or concave your, so it's doming or dishing the bed. So you always want to do the height map once your bed is up to temperature. So I'm going to get the bed up to temperature, run a height map, and then send this print. All right, well, this is printing nicely, so let's just simulate a filament runout condition where the spool has that kink in it. Sometimes there's a kink in the spool when they wind up the spool. And as you saw, it literally just sucked through, straightened out that kink as it was pulling it through, and now we are ready to replace that filament. Don't forget to feed it back through the filament runout switch. All right, well, that looks pretty good. We're getting good bed adhesion all the way around. You can see there the little bit of extra filament that got added from the extrusion move when I re-upped the filament, when I reinstalled the filament after we ran out of filament. So that is working perfectly. Now I want to give this direct drive extruder a little test by printing some flexible filament. I've got this super flexible and stretchy, might as well be a rubber band, this filament here from Filamentum. This stuff is 92A hardness, so extremely flexible TPU. Now the thing about TPU prints is you don't want to do them on your PEI print surface, because TPU and PEI can combine the same way as that other print bed that I showed you at the beginning of the video, and you would ruin your print surface. So best to preserve this bed as long as you can. And to that end, I'm going to be using a piece of glass here. So this has been cleaned. There's nothing on it. It's just cleaned with rubbing alcohol. And we'll just put that on top of the bed there and put some clips at the back. That should hold it in place nicely. Now the problem is the fact that this bed is a whole lot more thin than the piece of glass. Thankfully, we've got a BL touch sensor that touches the bed and measures the bed directly. So we can easily compensate for the thickness in the glass by just sending a new G29 command. Home all, G29. I have it set for printing at 220 degrees with the PLA, so that should work just fine for this TPU as well. All right, well, that's enough of that. I don't want to waste any of this valuable filament. I really like this stuff and want to preserve it for when I actually need it. So let's just take the bed off and get a look at that. We can see perfect bed adhesion all the way around, just like previously with the TPU print. So yeah, that works. You can easily change up the print surfaces as your needs dictate.
So I decided to create some new test print geometry just for the fun of it. This is a 30 millimeter dice or die, I guess, so it's singular die. Anyway, yeah, I'm going to print this out of the flexible material, and it should just be a fun little fidget toy, basically. But hey, if you want access to this test print geometry or really any of the digital files I've made for this video or any videos for any of these printers, I give those files out to my $5 Patreon supporters. It's not something I'm trying to sell. It's just like my reward. Thank you. Thank you guys for supporting me. And if you want to just toss me $1, you can do that over on Patreon as well.
I just finished printing a single dice with that flexible material. Let's peel it off the bed and take a closer look at it. So we can see the layer lines, and the ghosting, rippling, doesn't look too bad. I mean, TPU prints really slowly, so yeah, it's not too bad. Looks good. So this is a fun little toy for my kiddo to play with. And yeah, no under extrusion, so that means that the direct drive is doing its job, and I couldn't be happier. This is going to be a really nice printer now for printing flexibles and pretty much all kinds of everything. So I'm pretty happy with that. Here is the rundown of the pricing for this exact printer that you've seen me build in this video. But there's still some cost savings to be had, so this is the way that I suggest you build it. You can save $40 by using a Duet Maestro board instead of the Duet Wi-Fi board. Now, I already covered that Duet Maestro doesn't work for me because my wireless router is 2 rooms away. But if your printer lives right next to your wireless router, it's really no big deal. Save the $40. You'll still have all the functionality of being able to access your printer through the web page. So yeah, that's a great option. Another place to save some money is by buying an ultra base bed. Now that's the name for the etched borosilicate glass that you can get on eBay, and that's about a $25 savings there. But the biggest savings by far is by buying an Ender 3 instead of the Ender 3 Pro, and you will notice no difference. Nobody should do this with an Ender 3 Pro. I mean, I don't know why these sell. The Ender 3 is the undisputed sales king for consumer level 3D printers. Look at this this chart here. That's the Google Trends that show the search popularity of Ender 3 versus Prusa. So yeah, Prusa was the printer to beat. They had the internet by storm, or whatever, had the internet by storm there. Everybody was convinced that this is the shape of a successful, good 3D printer that you want. And that was achieved through some questionable marketing tactics. They basically have a Russian troll farm, tons of fake user accounts that they plaster all of the forums with, from Hackaday to YouTube videos to the Reddit 3D printing channel or subreddit, whatever. Most of those fanboys are manufactured screen names. You do get real genuine fanboys who have fallen for the manufactured trolls. Anyway, that marketing effort is the reason that this Mendel style frame is the thing that customer perceptions, everybody thinks that this is what a good 3D printer looks like, and that's just not the case. This is what a cheap 3D printer looks like. This is what an extremely value engineered printer looks like. But a better printer for the money would be a Core XY printer of the same size. And the Ender 5 is not Core XY. I know that the Ender 5 is very popular, lots of people talking about it, but the Ender 5 is not much better than this because it has the X-axis stepper motor, which is constantly moving back and forth with whenever the Y-axis moves. So it's no different than a direct drive. The inertial mass is still terrible. With Core XY, you don't have that inertial mass problem. So I don't know why the Ender 5 is such a good seller. Why doesn't Creality make an actual Core XY? Why doesn't Prusa make a Core XY? Like, they should absolutely be giving us those options, and they're not. But let's talk a little bit more about Prusa for a minute, because there is definitely good reason to buy a Prusa printer. If you just want a printer that works straight out of the box and there's no hassle, and if it doesn't work, there's customer service for you to call up and yell at, Prusa definitely is appealing. It will work far better than anything from China straight out of the box. You have to upgrade the printers from China to get the same performance. But that's kind of the whole point, right? We're all DIYers and makers. That's why we're attracted to this avocation, this hobby of 3D printing. So why would you just buy a turnkey solution, right? Why not have pride and enjoy the process? It's just really fun, and it feels really good once you build a printer and it works. So I think that is just way more appealing to me than buying something from that somebody else figured out and solved, and they get to be all egotistical about how good their product is. Anyway, I think that's about all I can say. Kudos to the guys who stuck around. I think this video is going to be longer than an hour when I'm all done with it. That was not the plan. This was supposed to be a quick project, but hey, it is what it is. So thank you so much for watching. If you like what I'm doing, support me on Patreon. This is a video that YouTube thinks you're going to want to watch if you're not already full up with hearing my voice. So yeah, thanks for watching. See you next time.